Alright, for today's video we're going to go over this old Magnatone 421 guitar amplifier that I found recently in my repair pile. This is a really cool amplifier that Magnatone made after they were acquired by the SD Organ Company, and they started making really cheap amplifiers. And but they did have this really cool vibrato circuit in them, and they used all these obscure tubes, and so I've had this one for about 30 years, and it always had a really bad hum problem that I couldn't figure out, and so I didn't know if it was broken, if it was inherent. I tried replacing the capacitors, and it still hummed really bad. So I finally decided to take it out and just make it work right. Just do some updates to it and some things like that to make it to where it was usable, so I could see what this tremolo sounded like, or this vibrato circuit. And Magnatone had a really interesting vibrato circuit in that it used a device called varistors, and what those are is a voltage dependent resistor, basically. So when the voltage changes across it, the resistance of the device varies a little bit. Now this particular amplifier, there were two versions of the schematic, and this is the earlier version that was stapled to the inside of the amp when I bought it, and this is the later version. And the differences are that there was a slight change to a resistor value in the oscillator of the tremolo circuit, and there was a grid resistor added in series with the phase inverter tube so that it wouldn't smash out and sound real fuzzy, and then a couple of capacitor type changes, probably because of oscillations. Anyways, this amplifier had 2 or 3 of those changes done to them already, but not the grid stopper resistor, so I added that, and it made a pretty big improvement to the way it sounded. Anyways, the power tube that it uses is a dual pentode called a 6HU8, and it's really expensive, and I had one that I had bought several years ago when I first got the amp, and when I replaced it, obviously it did the same thing. It hummed really bad, and but it did sound like it had some promise underneath it. It was a good sounding distortion to it. The front end tube here is what's called a 6AV6, which is basically half of a 12AX7, but it's kind of a little tiny 7-pin job. It's just a real simple triode in there with a sleeve, but it breaks up pretty nicely, and it seems to do fairly well. But what's cool about this particular application for the 6AV6 is that it's used in a grid leak bias setup, basically where the cathode's grounded and you have an extremely high impedance which develops a little bit of a negative voltage on the grid, and then a 270K plate resistor, which is really high for a 12AX7 stage. But anyways, it's pretty effective because you have 3 inputs on this amp. Really, the only one that's super useful is the highest one, because it bypasses this 47K resistor that shorts to ground. You don't want to have an input impedance that low on a guitar amplifier in general, but they're useful. But this one sounds right, and you can turn the volume on the guitar down and get a lot of dynamics, whereas on these others you really can't because of the low impedance to ground. But anyways, the other changes I had to make to it included, let me unplug it here. The main thing was that it needed a tremendous amount of filter capacitance. So I added 2 470 microfarad caps, and then a 100 microfarad per stage off of the pi filters that come off of the power supply. And then also the heaters were they were AC to every tube, 6.3 volts AC. And there were one side of the AC was grounded to the chassis, but then subsequently one side of it was also grounded locally at each tube. So I disconnected it at each tube and left it floating at one point on the chassis, and then tested to see which was better, and it was better with one side grounded in one point. I left as much of it as original as I could as far as the parts testing okay. I did change the first plate resistor from this carbon film part, which I left there just in case you wanted to compare them, with a metal film part that's a lot more stable than a grid leak bias circuit. I was tempted to change the input resistor as well to 22 meg, but I decided to just leave it alone because that's a odd value, and most of the noise that's left that comes from it that's not hum from the heaters in the first stage is actually a result of the shot noise in this because of the negative DC voltage developed across it. Okay, and also, what else did we have here? I did replace the filter can first. I just shotgunned it because I happened to have one, but it just didn't have enough capacitance. It was just designed to be really cheap. Another thing is that the cheapest way to make a chassis is just take a piece of sheet metal and bend it into a Z. And that's pretty much as cheap as it gets right there. But it did have a really high quality power transformer, which I'm assuming is left over from an organ of some sort, you know, that they were trying to use up parts on guitar amplifiers to get rid of leftover parts maybe. Because I believe that because it has this really odd, since it has a center tap, they used a full wave rectifier, and that's why it needed more capacitance. You could develop a lot more voltage off of this supply with a full wave bridge rectifier, but they chose not to, probably because of the tube complement, the output transformer, and other things that they had laying around. So anyways, that is pretty much all that I had to do to make the amp completely usable. Now, the other cool thing about this varistor circuit is that most Magnatones, the nice ones, had a stage, this Vibrato tremolo circuit here, which is, this is the oscillator for it, and I slowed it down. I slowed the oscillator down because I liked the way it sounded with the slower rate. I slowed it down by changing that resistor to like double the value, I think at 820K. And then that oscillator modulates either the bias of the power amplifier for the tremolo or the vibrato circuit, which is just basically this 12AU7 stage with a setup like a phase inverter, with the negative half going to one varistor and the positive half going to another varistor through a little network to offset the phase, and they sum back together here, and this modulates it to change the input gain of that stage. So it's pretty cool. It gives you a pitch shifting effect. The normal Magnatone version of this had two of these stages subsequent to each other that were both being modulated. What I thought was interesting about this amp was that it only had one, and so that's kind of a different effect that you don't really hear a whole lot. It's pretty interesting. So anyway, also I have the cabinet, and we're going to put it back together and listen to it completed before too long, but it had a 3.2 ohm speaker, which I changed to an 8 ohm speakers to make the external speaker jack that's already on the amp more effective when you go into another cabinet. So anyways, also let's look at the modulation waveform on this. For the low frequency oscillator in the vibrato circuit, you can look pretty much anywhere in the chain and determine whether it's oscillating or not, but you can always look here on the output of the intensity control, or you know, maybe right in there. But what it looks like on a scope is basically here you set it to some real low frequency, and let's see, that's a pretty tall signal there. There we go. And that's not what we want to see. We need a little ground. I unplugged it here. Let's see. That'll come up. And there's the low frequency oscillator for the tremolo. As you can hear, and when I change the speed to slower, you see it slow down. So that's what you look for on a scope with this, and it's like a triangular waveform because it's an RC oscillator. Anyways, this is basically what it sounds like through a much larger speaker. We'll put the amp back together and play it better lately. I had hernia surgery about a week and a half ago, and so this is a really bad guitar to be picking up, but I think I'm going to make it. There's the vibrato. You can hear the pitch shift a little. that's at the full speed. Or this is at the slowest speed. And there's at the highest speed. Turn the amp down a little, and then the tone control is actually pretty effective. It provides a little high-end boost when it's all the way up on one of the tube stages by bypassing it with a small capacitor. Now the tremolo on here is much more like you'd expect. So anyways, this is the Magnatone Vibrato circuit that I've been wanting to hear, just the one stage version. Alright, so next we're going to put it back together and see what we got. Alright, so I went to put it back together, and I had one of these big gigantoid capacitors glued back too close to the edge, to the chassis here, with some wire ties. So what happened was, when I went to put it back together, this is the best chassis to work on when you're having a hernia repair, because it weighs like 2 pounds. Anyway, I got it in there and it's like, bam! Nope. Alright, so now what I got to do is take it and move it up here, basically. And then I'm just going to take some like clear weld and just kind of glop around that bolt right there, and I can always go back and cut it if I need to get it back off. And that keeps me from having to really modify the chassis or drill a lot of holes and get it knocked out. I decided that I'm going to keep this amp because I really like the way it sounds. It's really fun to play through. Also, another word about the varistors. What I found out, these varistors here, these are the actual ones that are used for the vibrato. I don't really have any specs on them, but what I noticed was that the cold resistance of these when it's off is about 4.8 to 5 mega ohms. And I took some dynamic AC measurements with the oscillator on with a low frequency AC meter to see to calculate what the resistance was changing to when they were working. And the top one was around 920 kilo ohms. The bottom was around 3.4 mega ohms. So they're varying by anywhere from 1 to 4 to a 4 to 1 ratio, depending on the voltage across them. And they may have a lot of tolerance issues as well, but anyways, I thought that was pretty interesting. So without further ado, I'm going to go back and re-glue these, put the amp together, and we're going to take it for a spin. Alright, and so here's the Magnatone 421 all reassembled. I was able to find an 8 ohm version of what PV used to use in the classic 50. I guess it's like what would have been in the Delta Blues 210. It's like an 8 ohm 10 inch eminence, really nicely voice speaker. Also, and I made a grill here for it out of 1/8 inch masonite, a piece of masonite that I found in my shop there, and just cut it out with a saber saw right quick. And I found this grill cloth that we had salvaged from the old PV Guitar Factory at Plant 2, and I found this roll of sample cloth from the 60s up there that had never been used on anything. It worked out pretty nice. And what I did here to make it fit really tightly in the grill was I cut it to where it was really tight in there, so it's going to be a compression fit. And then to keep the sides from rattling up against this flat baffle, since there's no separate grill frame, I put contact strips in all the places where there'd be a long void, so the corners are not really going to rattle because they have cover material bunched up here. So to make up for that thickness, I just put some little Velcro contact strips there. So to put that in, I'm just going to kind of force that sucker in on all 4 corners. And the tab's already a little tore up. May go back and do some like little touch-up paint on that someday, but kind of work that in there. And I had the grill cloth stapled on there really tight, so all that. Now these contact strips, they're really strong. I think they hold about 30 pounds. So to make sure that they snap in, you want to take like a kind of a soft hammer and just give it a little, you hear it go crunch. And another one here. You hear that crunch there, that's a good, nice, tight grill cloth there. Now you could even take a hair dryer on this grill cloth that's got a lot of nylon in it. You can take a hair dryer and just kind of heat it up, and it'll just kind of pull too a little bit and tighten up if you have any problems with rattle, but I think we're probably going to be okay right there. So there's our nice new grill cloth and our new Magnatone 421. Now I've also considered putting some of these on there, the old PV knobs. And then also what I really want is some of the old mixer knobs that they used to use, the big black ones with the pointers. So maybe I'll look for a few of those. And then we'll get this plugged in to test out. Alright, well I got the amp together and I got my new grill on there, and I found some old the 60s PV knobs that I put on there so I could have some pointers, and it came out pretty nice. I used this spray-on material that's supposed to be for the undercoating on cars because I just happened to have it, and I was curious as to how it would look because I was going to make a new cabinet for it anyway if this one was unsalvageable, but it actually came out pretty good. It's kind of a flat, nasty color, but it works. And so anyways, I finally got this Magnatone 421 that I've had since high school fixed and working the hums out of it with a little bit of redesign. So we're going to do a sound test right quick just to show you kind of some of the sounds you could expect to get from one of these if you were to fix the hum problems with it and things. I'm using a guitar that's a little too heavy for me to pick up, so I'm just going to stick with this one until the video's over and then hand it off. But it's got some pretty moderately hot P90s in it. It pretty much does the thing, you know. So anyway, with the volume on about a quarter of the way in the bridge position. And the neck. That's no fun though. So the tone control basically is, before I get into any of the grit, what you have here is it's like a sort of like a cut and boost trick where they have a capacitor in the bottom half of the pot that actually, when you short the pot, the wiper goes to ground and the capacitor goes into a parallel connection with a resistor in the cathode of that tube stage, which bumps the highs up a little bit and sounds kind of cool. So basically you go from dark right at the end to that little spank on it. Control. It gets fun when you cut the volume up about halfway. It's on the bridge. And then this pretty throaty sound there, you bring the tremolo in. All the way down. Here it is all the way up. Then we go to the vibrato. We turn the intensity down for maximum effect here. Vibrato. Half intensity, slow speed. Maximum intensity, slow speed. That's on the deck, which I personally like. And on the bridge, it's higher speeds. Get all 6 watts cranking out of it. That's on the bridge. Boxy little amp thing kicking. That dual Pinto 6HUH is really good sounding too when it breaks up. And of course, with it on 10 and everything, if I had an external speaker going and could get it to feedback, it does this pretty well. Just a fun little amp. It breaks up really nice. The hum from the amp's not really so bad. I have some just regular lights in here, and these are that's the hum from the P90s, which they're allowed to do. But anyways, really cool amp, and wanted to put a video out there on it that showed what it could do. Also, I wanted to mention that I put an 8-ohm speaker into it so that the external speaker would match up well with an 8-ohm cabinet that I have, because it's supposed to be a 3.2 or 4-ohm speaker. And I used it's an eminence speaker. It's like a classic 50 speaker, but it's 8 ohms, similar to what was in the Delta Blues 210. Anyways, if you have any questions or comments, if you have one of these you're trying to work on, just give me a shout in the comments, and I'll try to help you out as best I can. Anyways, thanks for watching, and please hit like and subscribe, and we'll come out with something a little better soon. Thanks.